Welcome to this explainer. Let's just dive right in, because today we're uncovering the hidden infrastructure powering the absolute next generation of AI agents. We are looking at a really fascinating mystery here. How exactly can one AI suddenly connect to thousands of different applications without engineers having to sit down and write thousands of custom integrations? To understand the sheer magnitude of this breakthrough, we kind of have to look at the alternative. I mean, imagine the absolute chaos inside a software company if every single AI assistant required a bespoke, custom-built integration from scratch for every single app it touches. It is a developer's worst nightmare. Every new tool would mean endless, repetitive engineering work. In computer science, this is known as the dreaded N times M integration problem. Think about it. 10 AI apps and 15 tools means you need 150 brittle, unique integrations just to keep the lights on. But what if we could collapse all that complexity? What if we could turn N times M into a simple N plus M using just one universal adapter? Chapter 1, the integration nightmare. Let's look at why this is such a massive bottleneck. Let's set the stakes for a second. Right now, large language models are essentially isolated giants. They have these incredible reasoning capabilities, right? But they are completely cut off from the real world. And the impact of this is staggering. With roughly 90% of enterprise data sitting unstructured and siloed, a massive 60% of AI projects completely fail. And here's the kicker. They don't fail because the AI isn't smart enough. They fail because the underlying infrastructure simply cannot connect to it. So, how do we fix it? That brings us to Chapter 2, the Universal Connector. Fortunately, there is a hidden infrastructure being built right beneath our feet to solve this exact chaos. Enter the Model Context Protocol, or MCP. Originally designed by Anthropic, it's a standardized, open-source communication layer. And its real genius is in the separation. The AI model handles the complex reasoning, while secure, external servers handle the actual data access. Engineers have this perfect shorthand for the breakthrough. They literally call it the USB-C port for AI. Think about how you finally stopped carrying a massive tangled ball of 5 different chargers for your laptop, your phone, and your headphones. It's exactly like that. AI models no longer need custom scripts for every single database they want to query. MCP acts as that universal adapter, speaking one common language across the board. And this represents a fundamental philosophical shift in software. Traditional APIs were built for humans, people who can manage authorization tokens and format rigid, hard-coded web URLs. MCP, on the other hand, is built natively for AI. It assumes the caller is intelligent but untrusted. It dynamically tells the AI what tools exist and how to use them using natural language, like simply exposing a capability to get_weather. Chapter 3, Inside the Protocol. Let's actually pop the hood and see how this plumbing works. To truly understand this, let's trace a single complex request. Say you ask your AI to summarize your GitHub issues and drop a report into Slack. You make the natural language request. The AI decides, okay, I need external data. It uses MCP to negotiate capabilities, reaches through the server to execute actions on both GitHub and Slack, and then seamlessly synthesizes that final response right back to you. This whole seamless flow relies on a very strict 3-part architecture. First, you have the host. This runs the AI and the user interface, like Claude Desktop or Cursor. Inside that is the client, which maintains the secure connection. And finally, the server, a lightweight backend service using a standard format called JSON RPC 2.0. The beauty here is the incredibly clean separation of concerns. The AI reasons, the server executes. And running on top of that architecture are 3 core primitives: tools, resources, and prompts. Tools are executable actions, like querying a database. Resources are read-only data, like looking at static files or logs. And prompts are user-crafted templates. This strict structure guarantees that whether an AI is reading a local file or firing off a remote terminal command, the underlying communication is identical and completely predictable. Chapter 4, Powering AI Agents. So, why do autonomous agents absolutely need this protocol to survive? Look at it this way. If MCP is the standardized USB port providing the connection, and RAG, Retrieval Augmented Generation, is the reference library where the AI looks up specific facts, then the AI agent is your autonomous employee. The employee uses both the connection and the library to plan, reason, and actually execute complex multi-step workflows on your behalf. By leveraging MCP, these agents cross a massive threshold. They can receive a request, break it down, and crucially, they can dynamically discover and inspect available tools at runtime. They execute an action, evaluate the output, and chain it directly into the next tool as an input. It literally transforms your AI from a passive, basic chatbot into a dynamic, autonomous problem solver. Now I know what you're thinking. With great autonomy comes terrifying risk, right? Allowing models to execute code and query private databases means security cannot just be an afterthought, and it isn't. MCP bakes in the principle of least privilege. It demands explicit user consent gates for any sensitive or destructive actions, uses strict JSON schema validation to block prompt injections, and tightly isolates local from remote transports to stop hijackers dead in their tracks. Chapter 5: The Future of Software. This is all building to a grand, industry-altering vision. We are rapidly moving toward a digital landscape where every single piece of enterprise software, every cloud platform, and personal device natively exposes an MCP server. Like we said earlier, today's APIs are built for humans to write code against. Tomorrow's are being built entirely for AI agents to discover autonomously. The walled gardens are opening up. So, here is the crucial takeaway. The next massive revolution in tech won't just be about AI models getting slightly smarter or having a bigger context window. It is going to be driven by a universal language connecting those models to everything else in the world. MCP takes bespoke, fragile glue code and turns it into highly reusable, rock-solid infrastructure. To wrap up this explainer, here are 3 key insights you absolutely need to remember. First, MCP finally solves the N times M integration bottleneck by standardizing how AI safely talks to the world. Second, open standards unlock massive ecosystems. Just look at what USB did for hardware or HTTP did for the web. And third, AI only truly changes the world when it can act and execute rather than just passively answering our questions. We'll leave you with this final provocative thought to ponder as this technology rolls out. If the entire future of AI hinges on interoperability, what happens to your workflow, your business, and your daily life when every single application you use speaks the exact same language?